Light travels at an astonishing speed of 186,282 miles per second, making it the fastest thing in the universe. Yet despite countless attempts to imagine faster travel, physics tells us that nothing with mass can ever catch up to, let alone surpass, this extraordinary cosmic speed limit. To understand why, we need to examine how objects behave as they accelerate. When something moves faster, its kinetic energy increases, but approaching light speed makes this energy requirement explode upward at an extreme rate, demanding more than any realistic source could provide, even hypothetically. Einstein's theory of relativity explains that mass and energy are deeply connected. As an object accelerates, it begins to effectively gain more mass from the perspective of the universe. This increase is subtle at low speeds but becomes enormous as the object nears the speed of light. This rising effective mass creates a major problem. Pushing a heavier object takes more energy, and as its velocity climbs, the amount of energy needed rises steeply. By the time it reaches extremely high fractions of light speed, it becomes nearly impossible to supply the required energy. If you try to push harder, the universe pushes back. Relativity predicts that the energy needed to continue accelerating grows without limit. At 99% of light speed, an object already demands massive energy, but going even slightly faster would require exponentially more energy. Eventually, the math becomes unavoidable. To accelerate any object with mass to the exact speed of light, you would need infinite energy. Since infinite energy cannot exist in any known physical reality, reaching or exceeding light speed is fundamentally out of reach for anything with mass. Another effect appears as objects accelerate. Time slows for them relative to the outside world. This phenomenon, called time dilation, becomes very strong near light speed. From the traveler's perspective, time may feel normal, but the universe around them ages much faster. Space also begins to distort. Distances in the direction of motion shrink from the viewpoint of the fast-moving object. This effect, known as length contraction, makes the universe feel compressed. These distortions aren't optional, they are required by the laws of relativity. These combined effects, rising mass, slowing time, and contracted space, create a physical barrier that becomes stronger the faster you move. The universe is essentially structured so that nothing with mass can break through this barrier, no matter how advanced the technology. Even inside the world's largest particle accelerator, where protons race through a 27-kilometer ring at 99.999% light speed, physicists hit a wall. No matter how much energy they add, the particles simply refuse to reach the final fraction. If something could exceed light speed, it would break causality, making events happen before their causes. Physics relies on cause and effect, so faster than light travel would unravel the structure of reality itself. The universe forbids it to protect its internal consistency. So light speed is not just a number, it is a built-in limit woven into the fabric of space and time. It marks the ultimate boundary for motion, energy, and information. No matter how far technology advances, the speed of light remains the final, unbreakable rule of the cosmos. That's it for today's video. If you enjoyed exploring with me, don't forget to subscribe to Science Lab, where we turn everyday things into scientific discoveries. See you next time.